Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about solid mechanics and material subject. So in this subject, already we have discussed about various stresses and strains. So in today's session, so I want to discuss about our question bank. So we have discussed about simple stresses and strains, and then also we have discussed some problem solving questions. And now we will see how to attempt the given question in an examination. So at the end of the course, the student should be able to explain the concepts of stress strain, material constitutional relationships, and strain energy induced in linear, elastic, homogeneous and isotropic materials subjected to forces. So these are the outcomes after completion of this topic. The student should be able to answer, able to explain about this stress strain and material constitutional relationships and this strain energy. So the question bank, the simple stresses and strains. So in question bank, first you take one question, that is define stress, strain and explain their types. So whatever you studied in theory, you should give answer, the stress, what do you mean by stress, what do you mean by strain, and explain how many types of stresses and strains are there. And then do this problem. A circular rod of diameter 20 mm and 500 mm long is subject to a tensile force of 45 kilonewtons. The modulus of velocity for the material is 2.1 into 10 to the power 5 Newton per mm square. Find the stress, strain and elongation of the circular rod. So these are the given questions from the question bank. Now explain stresses and strains and then types of stress, and then we will see the given problem. So what do you mean by stress? When an external force acts on a body, the body tends to undergo some deformation due to cohesion between the molecules. The body resists deformation. So this resistance by which material of the body opposes the deformation is known as strength of material. So whenever an external force acts on a body, the body tends to undergo some deformation. So because due to cohesion between the internal molecules, so some resistance for oppose this deformation, that is called as strength of the material. But behind the elastic stays, the resistance offered by the material is less than the applied load. In such case, the deformation continues until failure takes place. So within the elastic stays, the resisting force equals applied load. This resisting force for unit area is called stress or intensity of stress. This resisting force for unit area is called as stress or intensity of stress. So already you know the stress here shown tensile stress. So the area of the bar, that cross-sectional area, and here calculated the stress load for area. So direct or normal stress is calculated by using the formula. So that formula is applied load by original cross-sectional area resisting the force. So which force is resisting whenever the body is subjected to external load? So that is called as stress, load upon area. So in the SI units, the force is expressed in newtons and area is expressed as meter square. Hence, the unit of stress becomes as Newton per meter square. Then you can convert into centimeter square and mm square. So the area is also expressed in mm square and then the unit of force becomes Newton per mm square. So tensile stress. So now we have discussed about stress and stress definition and units. Now the types of stresses. So there are tensile, compressive, shear stress. So first we will see the tensile stress. The stress induced in a body when subjected to two equivalent pulls, as a result of which there is an increase in length, is known as tensile strength. So I will show you in the diagram, whenever the body is subjected to tensile, so that is subjected to two equivalent pulls, the tensile stress acts normal to the area and it pulls on the area. See in this figure shown, this object is subjected to tensile load. Here cross section taken XX, at this shown the resting force. So the tensile stress, now calculate the resting force R upon cross sectional area. So resting force here, tensile load. Why? Because this one is subjected to tensile load. So that the tensile stress is equal to load upon area. So the ratio of increase in length to the original length is known as the tensile strain. The stress is load upon area and then strain, the ratio of increase in length to the original length. So what is the original length? Here shown. What is the increase in length? Increase in length here shown with DL, extension or delta L. This is some deformation due to this tensile load. So the strain is the ratio of increase in length to the original length. So tensile stress is given by increase in length by original length, TL by L or delta L by L. So the compressive stress, the stress induced in a body when subjected to two equal opposite pushes, because of which there is a decrease in length of the body, is known as compressive stress. So the compressive stress adds normal to the area and pushes the area. So here shown diagram, there is a decrease in length of the body known as compressive stress. So the compressive stress adds normal to the area and pushes the area. So here pushes this area and resistance for shown here, the compressive stress is given by resisting force upon area. So the resisting force is R, and then push load is P and area is A. So that the compressive stress is given by P by A. So units already you know, Newton per mm square, or Newton per mm square, or Newton per meter square. Clear? So the ratio of decrease in length to the original length, increase or decrease. The decrease in length of the original length to the original length is known as compressive strain. Here, the decrease in length of the previous one, increase in length to the original length. Compressive tensile strain, and this one is compressive strain. So now here decreased. So the shortening, the length decrease. The ratio of decrease in length to the original length is known as compressive strain. That is delta L by L. So now the shear stress. We have discussed about tensile stress and strains. And shear stress, the stress induced in a body when subjected to two equal and opposite forces which are acting tangentially across the resisting section, because of which the body tends to shear. Shear off across the section is known as shear stress. So the shear stress is the stress which acts tangential to the area. It is subjected to force represented by T, the tangential area. So here the shown diagram, here example given, the riveted joint that is subjected to tensile load, how it is shear, shown in this diagram. The previously this one, and after shearing, shown in this. So two equal and opposite forces which are acting tangential. So the shear stress is the stress which acts tangents to the area, that is called as shear stress, shown tau. See the shear stress, shear resistance upon area. So the shear resistance R upon area. Shown in this diagram. So it is a measure of the angle through which a body is deformed by the applied force. So denoted by psi. So shown in this diagram, how much deformed. So in this diagram shown, so whenever it is deformed like this, so what is the angle? The shear strain is represented by the angle through which the other two faces have rotated. So as the bottom face of the block is fixed, the face ABCD here shown, this one is fixed. Clear? So the face ABCD will be distorted to ABC1 D1 through an angle psi as a result of force P. ABC1 D1 and not shown here. AB, C1, AB is fixed, and C1 and D1. This is after deformation. That result of force P. So as the bottom face here shown clearly after deformation, the bottom face of the block is fixed. The face ABCD will be distorted to ABC1D1 through an angle psi as a result of force P. So this is in this deformation DL and this DL. This side CC1 deformation. So as the bottom face of the block is fixed, the face ABCD will be distorted to ABC1D1 through an angle psi. So as a result of force P. So now the angle transversal displacement upon distance AD. So the distance AD, transversal displacement is D1. Clear this one. And the distance is AD, that is H. Clear? So that is the answer. You have to write to the first question, that is define stress and strain. I will show you the question once again. Define stress and strain and explain their types. Clear? So come to the second one. So based on the above stresses given problem, so the rod 500 mm long and diameter 20 mm is subjected to an axial pull of 45 kilonewtons. So first of all, given data you should write. So in this, first clearly read the problem. 500 mm long and 20 mm is subjected to an axial pull of 45 kilonewtons. If the modulus of velocity of the material rod is 2 into 10 to the power of 5 Newton per mm square, determine the stress, determine the strain, and determine the elongation of the rod. So the stress given is length is equal to 500 mm and diameter is 20 mm. Is subjected to an axial pull of 45 kilonewtons. The load is 45 kilonewtons. If the modulus of velocity of the material of the rod is 2 into 10 to the power of 5 E. So now calculate stress, strain and elongation. So you know the stress, first bit, stress is equal to load upon area. So load already available, but area you don't know. So area of the cross section, find out area of the cross section. A is equal to 5/4 into d square. So what is the diameter here given? 5/4. So diameter is 20 mm. So 20 square. So 5/4 into 400, you will get 100 pi mm square. Clear? So next, strain. Strain is so how do you calculate the strain? Delta L by L or delta D by D. But here elongation now we don't know, not given, and L only you know. How do you calculate the elongation? So you know the Hooke's law relation. According to Hooke's law, stress is directly proportional to strain. Sigma. So you can write E epsilon. So that this strain is equal to sigma by E, you can calculate. So already you know stress value calculated, P by 45 kilonewtons into 10 cube, 45 into 10 cube by area 100 pi divided by E, 2 into 10 to the power of 5. So calculate strain will get. So this is delta L by L. So now you can calculate the elongation delta L into L into strain, or delta L is equal to PL by AE. So directly we can substitute in this form. So the given P 45, the given P is 45, delta L is equal to 45 into 10 cube into L is, the length of the rod is given 500 mm. So 500 divided by area 100 pi into 2 into 10 to the power 5. So you will get elongation. So stress calculated and strain also calculated and elongation of the rod also calculated. So by using stress strain relationships. So like this need to calculate the given problem on simple stresses and strains. So these are the references I have taken as Ramamurtham. Title of the book is 10th of Material, and Dhanpati Rai Publishing Company, and then R.K. Bansal, Textbook of Strength of Material, Lakshmi Publications, and R.S. Kurmi and Gupta, Strength of Materials, Chand and Co. So these are the references I have taken. Take any one reference for further more clarification. So you will get a good idea about this simple stress and strains problems, how to solve the problems whenever given data related to the stresses. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.